Okay, how to use cosine law. So these are non-right angle triangles we've set up. And we talked about sine law where you need that like opposite ratio. If you don't have that opposite ratio, then you have one of these two scenarios happening. Let's call this scenario A and scenario B. Scenario A happens when you have like a side, then you have the adjacent angle, and then you have the adjacent side to that. If you notice, I don't have like the opposite angle of that side, I don't have the opposite angle of that side, and I don't have the opposite side. So I can't use sine law in this situation.
Okay.
So I got to use this formula here. The other possibility is they give you all these side lengths. They give you all the side lengths. Again, I don't have any internal angles, so I can't use sine law again. One other scenario where you can't use sine law, I'm going to just quickly draw one here. Let's say 45 degrees. Oh, wait, is that right? 45? No, that's not right. There you go. 45, 45, and I don't know, 90. They give you all the internal angles and none of the sides. You can't use sine law, and you actually can't use cosine law because what happens here is these sides can be anything. We can't actually definitively tell because you can stretch and expand a triangle that can have these angles, but they can have different sides. So anyways, that's a super rare scenario. They're probably never going to give you that. These are the other scenarios. So can't use sine law in them, so we're going to use cosine law. It's common to be presented cosine law to have like another one's like b squared plus a squared plus c squared. Yeah. There's really no reason for that. You just memorize one and just get used to naming triangles using the A letter. If this is the one you memorize, technically there's one with a B and a C, whichever one you memorize. Just get used to using the A in this scenario as the either side you're looking for or the angle you're looking for. Just name that one A with this formula and it'll work. And you don't have to have 3 different formulas for this, okay? So let's say in this scenario here, we are going to be looking for, I'll call this x, and we'll call this one x, okay? Those will be our unknowns. So scenario A, actually I should do this one green because it's technically B. So scenario A, we're looking for that unknown side there. So like I said before, when we go to name stuff, just make sure you name the side you're looking for A. So this will be our A side, which means the opposite angle is A, okay? And then B and C doesn't really make a big difference. I'm going to call this B, which would make this angle B, and I'm going to name this side C, which would make this angle C, okay? Once we've done that, we've did our opposite sides, just like we talked about before. We make sure that we have opposite sides and angles having the same lettering format. We just do substitution. So side A is actually our unknown. That's really important here. So I'm going to substitute x in for the letter A, okay? So we're going to call that x squared is equal to, B was 7, so 7 squared, plus C was 5 squared, minus the number 2 times 7 times 5. Notice I'm replacing the C's there and the B's there, okay? And then multiplied by cos angle A, okay? So this is the angle here. And this angle in this case is 43 degrees. So I'm going to say 43 degrees. Now, one very, very, very common mistake is to calculate this, and then this number and like start subtracting. This is like a whole set of brackets. All of this has to be computed together before you start attaching it to these terms.
So after you multiply that, and then...
Yeah, so you multiply this, and then this is technically a number. You multiply by that. There's almost like 4 terms, and then you apply the negative to whatever it is, because technically you could call this -2 in multiplying. That will become a term, and then this is a term, and you either add or subtract it to this term, depends how it comes out, okay? Now it's just strictly calculating stuff. So I'm going to try to do this as quickly as we can so we can get to the second example. X squared equals 49 plus 25. Subtract, and that's going to be 35 times 2, 70, times cos 43, I won't know. Hey Google, what is cos 43 degrees?
The answer is approximately 0.731354.
731.
354.
354. I could probably ask to repeat, whatever. So this is what I'm talking about, where this is multiplication and this is like addition or subtraction. So if you think of BEDMAS, this has to be done first. It's very common for people to put these three things together, which would be incorrect, okay? So we're going to multiply that. You double check Google for us, okay? Hey Google, what is 0.73354 times 70?
Sorry, I don't understand.
Didn't get it. Okay. Do you have a calculator handy?
Yeah, I got it. Oh.
Yeah,
I don't
that's.
think so.
I think you missed the decimal place there. It's okay. If you watch this video, you can just listen to us trying to multiply on calculators. 0.73354. I got. Yeah, I think you just missed a step. So I'm taking, because it's negative 70. So think of it like negative 70 times that decimal value. We get negative or subtract 51.3478. Still I have 25. Still I have 49. I'm going to put those together. So that value, I'm going to apply, turn it into a negative. Plus 25 plus 49. All right. So we get 22.6522, whatever. It doesn't matter. Decimal. We're kind of rounding. Sorry. It does matter, but we're deep enough that we'll have a precise answer. This is squared. So in order to get this by itself, you actually have to square root this side over here. We use the opposite thing. That's how you eliminate or bring over a square. So we have to find the square root of 22.6522. And the square root of that should be, okay, x equals 4.76-ish, let's say. So if we were to plug that in this triangle, 4.76, let's quickly take look at our sides. This one's 43 degrees. This one looks like an obtuse angle, which would means it's even larger than whatever this side was. This one we have really no concept of because it isn't quite the scale, but this number fits decently with these other ones. We're probably doing okay, especially because 43 is like probably a quarter, 2/4 of a triangle, 2/3 of a triangle. So that is a potentially okay answer. Okay, so we've done that. Let's take a look at cosine law when it's sides, okay? So I'll shrink this a little. Oh my, that's not what I wanted. There we go. Okay, I'm going to write the same cosine law out again. So a squared minus, we'll call this scenario B, right? A squared is equal to b squared plus c squared minus 2bc cos angle A. What's important here is we're looking for this angle here in this case. Remember I said name the either side or the angle of the A in this course. So we're going to call this A, which would make this side A. And then I can call that B, which would make that angle B. And we can call this C, which would make this angle C. Angles aren't too important. Notice there's really only one input for an angle in this formula, right? So it's just got to make sure we name that one angle correctly. The rest of the stuff is all sides. So if that's the case, our side A is 3.2. So this would be a little different. 3.2 squared is equal to side B was 5.9 squared. C is 6.2 squared minus 2 times, I have room here, 5.9, 6.2, and then I'm going to try to squeeze it in cos A. Now, see, I could have just done that. Let's do that. Cos A. Now, we're actually trying to find the angle in this case. So we have to isolate for that. But before we go around rearranging this is where they sometimes show a whole different formula. We can do some calculating to like simplify these values, all of these things, and then isolate for A. Okay? So we're going to try to calculate a bunch of this, break it down to simpler numbers, and then finally find out what angle A is. This will need some calculating for. So 3.2 squared is 10.24. So we're just going to rhyme off a bunch of numbers. Not the most exciting stuff here. 5.9 squared is 34. Do me a favor, can you like just double check?
Yeah.
That way I don't make a mistake there. 6.2, let's say is 38.44. And then the next thing says negative 2 times 5.9 times 6.2. So I'm going to try that. Negative 2 times 6.2 times 5.9.
It's right.
It's right? Okay, so we have negative 73.16 cos A. Okay. If you look, this is a term that's positive and this is a term that's positive. We can just move them to the other side, essentially making them...
Oh, to subtract.
Exactly. So this becomes 10.24. Oh, that sounds happy. Oh, jeez. And then minus 38.44. Now, when I do that, this is still negative 73.16 times cos A. It's really important that we realize that this is like multiplication, because I can't just bring that over and make that positive. I actually have to divide that. We're going to simplify over here. 10.24 subtract 34.81 subtract 38.44. Did you get negative 63.01?
Yeah.
Good. And then, so this is like the harder way to use the formula. Then we got to divide by this, right? We got to move this to the other side. So this would become divided by negative 73.16. Technically, you're dividing both sides by this, and this is, they call it canceling out or creating a 1. So we end up with cos A is equal to that. Divide 73.16. Okay, so
what's...
So it's a negative divided by negative,
Oh.
so it's going to be a positive. And because the top number is a little smaller than the bottom number, it's going to be a number less than 1. So we get 0.8612 approximately. Okay, this is the other step that is a little less common. To figure out the degrees, we find the inverse of this cos. So when you bring cos over, because again we're trying to find just A, we get cos to the negative 1, 0.8612. Is equal to A. So have you ever seen that on a calculator with trig? Can I find it? The second functions. Here we go. Cos inverse. Okay, so sometimes you'll have to put like shift or second function of something, and then whatever that value is, I select this, and we get A is equal to 30.5
Okay, I
degrees.
see.
Okay, so that's the general idea to that.